Intermediate Algebra for Statistics, Finding Quadratic Models, Part 3. Determine whether to model a situation by using a linear model, quadratic model, or neither. We'll begin with an example. Example 4. Table 61 lists the percentages of workers in various groups who use computer on the job. Let P equal F of T be the percentage of workers who use a computer at age T years. Find an equation of F. So this is the year group, ages 18 to 25, and for the model we will use 21.5 to represent this age group, and the percentage in this case is 34.4%. So this will be our independent variable, this will be our dependent variable. So first we have to put the data in list 1 and list 2. Next we create the scattergram. This looks like a quadratic pattern. Hit stat, then calculate, then number 5, quadratic regression. Here we have the values of A, B, and C. We also have R square, which is about 0.96. So our function will be f of t equals a negative 0.051 t squared plus 4.089 t minus 28.140, rounded to 3 decimal places. We need to graph this equation to see how well it fits the data. Put that in list 1, hit graph, and we see this parabola is modeling the data very well. Use F to estimate the percentage of 22-year-olds workers who use computer on the job. Since we have the equation in Y1, if we hit the vars key, then the Y vars, then Y1, this pastes Y1 into the home screen. We now type in 22 and we get an output of 37.134. So according to the model, for 22-year-old, the estimated percentage of those who use a computer at work is about 37%. To do this algebraically, we take the function. We want to know what is the value of f when t is 22. So we substitute 22 in for t. So in this case we take 22 squared, multiply it by our value of a, plus 22 times our value of b, and then we subtract the value of c. And performing the arithmetic, we have a 37.134, just as the calculator told us. To answer the next question, what ages will half of the workers be using a computer? Half means 50%, so we want to know what values of t will make f of t equal to 50, because 50% is 1/2. So we take our model, we substitute 50 in for f of t, and then we solve for t. Our first step is to subtract 50 to both sides. Now the quadratic is equal to 0. A is equal to a negative 0.051, B is 4.089, and C is a negative 28.14. Plugging these values in the quadratic formula, computing what's inside the radical, we get negative 4.089 plus or minus the square root of 0.779361. All of that is divided by a negative 0.102. Taking the square root, we are left with this expression. And when we split those up, the first age is approximately 48.7 years, and the second age is approximately 31.4 years. To verify this using the graphing calculator, we can use the table feature. We can see when x is 33, we have the percentage a little bit more than 50%, and when x is 48, the percentage is a little bit more than 50%. Using the var key, which is short for variable, we can just type in 31.4 and we get approximately 50%, and 48.7, which is approximately 50%. So at those two ages, the model is predicting half the workers will be using a computer at their job. Next question. Estimate the age of the workers who are most likely, which means the maximum percentage, to use a computer on the job. What is this maximum percentage? Then find the T intercepts. What do they mean in this situation? So what is the maximum percentage means find the vertex. So using our formula, negative b over 2a, we have x is equal to 40.09. Now that's the year, so we have to take this 40.09 and plug it back into the model to get the percentage. Following the order of operation, we see that the percentage is 53.8%. So in the terms of this problem, according to the model, at around age 40, the maximum percentage of workers who use a computer at work is about 53.8%. To find the T intercepts, and what do they mean in this situation? T intercepts means find the value of t when f of t is equal to 0. So now we have a quadratic equation equal to 0 that tells us our values of a, b, and c. Plugging these into the quadratic formula, we get the expression negative 4.089 plus or minus 3.314, all divided by a negative 0.102. So the first t-intercept is 72.6 and the second is 7.6. So we would say, according to the model, the percentage of 8-year-olds and 73-year-olds who use a computer on a job is 0. Now, this is likely a model breakdown because 8-year-olds don't have a job and most 73-year-olds are retired. So this is likely a model breakdown. Our last example, example 5. Let f of a be the percentage of households who own a home at age A years. So here we have the age group 15 to 24. We will use 19.5, the midpoint, to be our independent variable, and then our dependent variable is the percentage who own a home. So for this age group, 18% own a home. A. Find the linear regression of f, round to 3 decimal places. B. Find the quadratic regression of f. C. Which model is better? Explain. And D. Using the best model, find the A intercepts. What do they mean in this situation? Is there a model breakdown? Explain. So for A, we enter the data in list 1 and list 2. We graph the data using our scattergram. To find the linear regression, we hit stat, calculate the number for linear regression. R square is 0.74. A, the slope is 0.934. B, the y-intercept is 16.99. Graphing the model with data, we see that the linear line is not doing a very good job of modeling the data. Finding the quadratic regression, we have r squared being 0.99, and if we graph this model with the data, we see that the quadratic is fitting the data set pattern very well. So our model is f of a equals negative 0.031a squared plus 4.019a minus 46.902. To find the a intercepts, algebraically, we would set f of a equal to 0 and we would use the quadratic formula to solve for a. I'm going to approximate the a intercepts using the table of values. Using a table of values, we see that somewhere in between year 12 and 13 we have a value of 0, and between the ages of 116 and 117 we have a value of y as 0. So this is likely a model breakdown because the normal 12-year-old doesn't own a home, and most people don't live to be 116 years of age. So a model breakdown has occurred. Thanks for watching.